guys, this is Britt Caswell with another example video. This is example 2 from lesson 1-5 in the SavvasRealize Algebra 2 textbook. In this video we are covering solving a one-variable inequality by graphing. Alright, the graphs in this section are done on the Desmos calculator, which is a free graphing calculator. I recommend that you either download the app to your phone or you just keep it open in another tab because it's super useful. So for this situation, we have an equation, x squared minus 4 is greater than 0. So in my graphing calculator on Desmos, I literally just typed in x squared minus 4. And what I'm doing is I'm looking for the x values which are producing numbers bigger than 0. Okay, so my y-axis, where y is 0, is kind of my boundary line. So I'm looking for anything on the graph. I don't know where those lines came from, but I'm looking for anything on the graph that is bigger than that 0 marker. So I'm looking for everything up here and everything up here. Okay, and I'm going to respond to it using an inequality, because this is an inequality. So I'm looking for some x values to describe these. So this tail that's on the left, it's shading to the left, right? It's going that way slowly. So I need to figure out the end point where this purple tail's at. I've gone ahead and marked that end point right here. It's at negative 2, 0. So I'm looking at all the x values where x is less than negative 2. Now, we have to figure out whether we're going to include that point, negative 2, 0. And so we're actually looking back at our main inequality up here. It says that it has to be greater than 0, not greater than or equal to 0. So I'm not including this point right here because it equals 0, and the main inequality doesn't say that it can equal 0. Alright, so now on the right hand side, we're starting here at x is 2, and then we are shading that way. We're shading to the right. So that is where x is greater than 2. And just like on our less than section, it doesn't say it can equal 0, so I'm not going to include the 2 here in my answer. So this is going to say and, okay, so it's going to have these two things. It might ask you in your textbook to separate it with a comma. I'm not 100% sure off the top of my head. Just look at how it asks you to format your answer. But those are the two answers. Ooh, that was exciting. Here we go. Here is a word problem. So there's a motorcycle that is 40 miles ahead of a car. So they kind of, they zoomed apparently. The motorcycle is going 40 miles an hour, and the car is going about 60 miles an hour. And they want to know when the car is going to pass that motorcycle, right? Because if the car is behind and it's going faster, it's going to surpass that motorcycle. So what we can do is we can create an equation based off this. Alright, so our motorcycle, it's a green motorcycle, so I'll use a green line. Our motorcycle is 40 miles ahead of a car. So already on the motorcycle side of an equation, it has a 40. But since the motorcycle is still traveling, the motorcycle is still going 40 miles an hour, I'm gonna include 40 times x, where x is talking about time. Okay, so 40 miles an hour here, or I'm sorry, 40 miles here, 40 miles an hour here times the number of hours. So this is talking about an amount of time on my x-axis. So then for the car, right, the car is starting kind of at a 0 point. Okay, but it is traveling 60 miles an hour, so I'm going to call it 60x here. So this is the equation that we are trying to solve, and that's what we're plugging into Desmos. Remember from my last video, you need to make sure on Desmos to call each side of the equation either f of x or g of x, like you see here, or else it won't actually graph your lines. Now, I want to show you guys something on Desmos, because when I did this, Desmos usually keeps the x-axis and the y-axis at the same increment. And what it did was it produced a graph that was almost impossible to read. So in order to get my graph to look a little bit nicer, I had to go through and I had to change some of my settings. So in the top right corner of the Desmos app, there's this button right here. It's a wrench. That is the settings as to how to adjust your graph. And so what I ended up doing here was I changed my x-axis. These values changed a little bit. I think I might have scrolled a little bit. But originally I said from 0 to 10, and I said the step was 1. And then on my y-axis, I changed it from 0 to 250 with a step of 50. And so what that did was it kind of made all my graph fit on the screen. So you might have to fiddle a little bit with the steps, which is how much it counts by, or how much is shown on the axis. Alrighty, so that might be helpful for you guys. Okay, so I got this graph, and I have this point right here. Let me see if I took another screen cap. I did not. So that point was actually at 120 on the y-axis. So it's the point to 120 right there, this yellow one. On Desmos, you can click on the point, and it will put the ordered pair there. I think that having my settings open got rid of my point, though. So in terms of the answer, alright, the answer here is our x value. So the car will pass the motorcycle after 2 hours. Right, because we said that x is counting in time, and it's in miles per hour, so that would be 2 hours. Alrighty, let's check out another one. Alright, so here we have the inequality, x squared plus 6x plus 5, so that's a parabola, being greater than 0. So I've gone ahead and I've graphed the parabola. Alright, this one was in your textbook. They had a Desmos built in. You see that? And so it works very similar to the first example, right? We are looking for the values that produced y values above 0, which is these kind of tail things here. So we need to describe the blue. So for this left tail, we're looking at -5 is the endpoint. And they're shading to the left of -5, right? It's all this stuff over here. So that's where x is less than -5. And then we have to think about whether or not we include this endpoint. So should this be less than or less than and equal to? So that's where we refer back to our original inequality. So on my original inequality, it says it can be equal to the 0. So here at -5, 0, that point is included because the value is 0 here. So we need to make sure to include it in our answer inequality. Alrighty, so now for the right-hand tail, okay, it kind of works the same way. The endpoint here is at -1. So I'm going to put x and -1. It's shaded to the right, so this is all the x values greater than that -1. And because the inequality says that it can equal 0, we need to also include this endpoint at -1, 0. So I'm going to put the equal sign here. Okay, so my answers would probably be an or situation here. Okay, so x is less than -5 or x is greater than -1. I probably misspoke up here on this first example. I'm going to fix that now. We should call that or. The phrasing here is very important, because if I say and, that's going to be where these two tails intersect and they don't. So I apologize for that error. Make sure to use or else they'll probably get a little fidgety in the book about it. Okay, here's number 2. I think these are the triads, right? So for number 2, what I did was I completely just typed that equation, that inequality, out in Desmos. And if you noticed, it produced a graph that's a little different. It has a little bit of shading on here. Okay, so if you have variables on both sides of the inequality, that's okay. It'll give you an answer like this. We just need to interpret that graph. So first thing, do you guys see that line right there, that dotted line? Okay, that dotted line is telling you that the inequality symbol that you're using is either the greater than or less than symbol, and it's not the equal to. It won't have the line that's under there. So if this is a solid line, it can be equal to, so you'd have the line. Here where it's dotted, you don't. Alrighty, and then they've shaded to the right of x and 1. So I'm going to have my x value, I have my 1. When they shade to the right like this is all the x values greater than 1. And we said it's not equal to. So this is the actual solution. Now, if on these inequalities, if I had chosen to put the greater than or equal to 0, it would also have produced a graph kind of like this, but it would have shown kind of a great divide. It would have shown you something like, here's -5, here's -1. It would have had a solid line here, a solid line here, and then shaded like this. Okay, so that's just showing the intervals. I have a hard time seeing that, so I usually prefer, if there's just a 0 here, I usually just prefer graphing this and looking for what's above the axis. But both of the graphs will get you to the same solution. So I hope that seeing those two solution types has helped, and until next time.